Hi everyone, this is Mrs. Kirk, and we are going to be learning about contingency tables today. Contingency tables, or you may have heard them called two-way tables, are another way to display categorical information. They allow us to easily see the relationship between two categorical variables. So here is a Venn diagram, and we have marching band and taking Spanish are our two main variables. So only 11 are taking marching band only, 13 Spanish only, and 12 people are taking both, 4 people are taking neither, and there's 40 students in our study. So what we're going to do is we're going to use this Venn diagram to fill out this two-way table or contingency table. So taking Spanish is this row, not taking Spanish is this row. In the marching band is this column, not in the marching band is this column, and we'll total everything up and have our grand total here. So our grand total we already know is 40 people. Okay, so we're going to fill that in first. So this column and this row should add up to 40. So taking Spanish and in the marching band, this is an overlap. So I'm just going to write it in small letters so we remember where this letter or number came from, and this is 12. They are taking both is the 12. Not in marching band is only marching band. So that would be 13 taking Spanish and not in marching band. So 13. So I'm going to call this S for Spanish and M for marching band, and then I can write only S. So only Spanish. Then we add those two things together and we get 25. So now we have not taking Spanish and in the marching band. So this would be only the marching band. And that's 11. So I total this up here and I get 23. And then not in marching band and not in Spanish. This is not to both, right? Which is just the 4. So 13 plus 4 is 17. And then 11 plus 4 is 15. 25 plus 15 is 40. And 23 plus 17 is 40. So we did that just right. Okay, so now we got to answer some questions about this table. So what is the probability that a randomly selected student from a survey is not in the marching band? So first I'm going to have the notation. The probability of not in the marching band has the apostrophe or the complement. So this is everything except in the marching band, right? So when I add up everything, it looks like I have not in the marching band. All of these people don't have marching band is just 17. So 17 over the total is 40. And when I put that in my calculator, I'm going to round out to 4 decimal places. So 0.4 something. Where's my calculator? Sorry, I want to make sure I have all 4. I don't think there is 4 decimal places. Oh, there isn't. It's just 425. So there's not any more values. It's a terminating decimal. All right, so what is the probability that a randomly selected student from the survey is taking Spanish class? So this is the probability of Spanish. And it looks like those taking Spanish, a total of taking Spanish is 25 over here, over 40. So in my calculator, that's 0.625. What is the probability that a randomly selected student is taking Spanish given that they are in the marching band? So we just love this word so much. This is the probability of Spanish given marching band. And so remember that is Spanish intersect marching band over marching band. So when I look for this intersection of Spanish and marching band, it's 12. So 12 is my intersection. And then just marching band in marching band is 23. And I'm going to put that in my calculator and get 0.5217. All right, last but not least, we have what is the probability that a randomly selected student is in the marching band given that they take Spanish. So probability of marching band given Spanish. So it's still the intersection of Spanish and marching band, which is 12, but then my denominator is Spanish. So again, I'm up here, the total people that take Spanish is 25. So my denominator changed a little bit. So I get 0.48 as my probability. Okay, just a reminder, we don't use percents in probability. We can change it to a percent if ever we needed to, but we are just going to primarily live in decimal and fractions. All right, so this contingency table is given to us, which is so nice. We have pets, people who have more than one pet, people that have one pet or no pets, and then we have the kind of pets. So like flying pets, I would assume is just like birds. I don't know, I guess you could have bugs that fly, but ew. They have invisibility properties. So I think we're talking about imaginary pets. Super strength, there it is. Super strength, let me see if I can focus this a little better. They have telepathic abilities, telepathy, and then the totals of all of those. So this is a fantasy pet project here that people had. So using this contingency table, we're going to find the probabilities, but they only gave us notation. So have no pets. So the total of no pets is 15. And the total pets altogether is 40. Now we can put that in decimal if you want to, which I get 0.375. Probability of a flying pet. Okay, that would be 14. Flying pets, 14 over the total. And that in my calculator is 0.35. And then we have an intersection, one pet, and telepathy. So intersection is, what did I say? One pet and telepathy. This is the intersection is 5. And the total is 40. And that is a reducible fraction, but let's just go ahead and put it in a decimal, which is 0.125. All right, so union is where we have to be super careful because they overlap in different places. So I'm going to put a little note here. The totals overlap. So let's look at more than one pet. More than one pet total is 14, but look what it includes. It includes the intersection at telepathy, the intersection at super strength, invisibility, and flying. So these, we're going to talk about invisibility. Well, this invisibility has 2 that overlap. So when we take these totals, we have to keep in mind that 2 is counted this way and 2 is counted this way. So if you think of it as a column and a row, this is where they overlap. So we don't want to count these 2 pets twice. So what I have is I have 11 plus more than one pet. Oh, I was in the wrong row, so sorry. It has more than one pet. So invisibility 3 here is where we overlap. So 11, I had the right number. I was just in the wrong row before. 11 plus, and then 10, but then I'm going to subtract off the 3 where they overlap. All over 40. So this is 18. And then as a fraction, or as a decimal, 0.45. So hopefully that kind of makes sense. When we're talking about going both directions, we're counting it twice. So probability of no pets intersecting flying. So I'll just put no pets intersecting flying. So if we're talking about given, this is the little formula. If you need to write it out every time, there is no problem doing that. But when I have the intersection is 7, no pets flying 7 over the total flying is 14, and this is 1/2, or 0.5. All right, last one on this table, super strength intersects more than one pet is just 1. And the total of more than one pet is 11. And that fraction does not reduce, but as a decimal, it's 0.0909, and it just keeps going like that. So the next number is a 0. I don't have to round. All right, last frequency table or contingency table. Okay, so this is different. This is a relative frequency table, okay, instead of a contingency table. So it's a little bit different. So what it means is we're actually putting the probabilities in there in place of intersections. So this is an intersection of flying and has more than one pet, but we're going to put the probability here. So that would be 4 divided by 40. So I'll just write it real small a couple times. 4 divided by 40, which is 1/10. So the probability is 0.1 or 1/10. We're going to use decimals in this whole table. So invisibility is going to be 3 over 40. And if you put that in your calculator, so we just calculate them, is 0.075. And you're just going to move like that across the table. Okay, everything is over 40 because that's our total, which means we have, if we had a 40 out of 40 down here, then that would mean we have a probability of 1 or 100%, right? So go ahead and fill that out. Have all of those filled in. We're going to do the same probabilities, but this time we should just be able to like point to it. So the probability of no pets is, right, probability of no pets, where am I at? No pets, no pets, no pets. 0.375. And if you look up here, we wrote that decimal already, but it shows up exactly where it should in our contingency table. So our flying pets, we have 0.35. In our intersection of one pet and telepathy, we have 0.125. More than one pet union invisibility, 0.45. And this one we might actually need to calculate the more than one pet and invisibility is a little tricky because you have the overlap of the invisibility that you need to make sure you subtract off. So no pets, we already know that's 0.5. And the given here, more than one pet, is 0.0909. We already did all of these decimals up above, but this kind of table is where you don't have to, it's already like pre-calculated. It just makes it faster for the things that you want to know. All right, that is the whole video, and we will practice more in class.